Okay. Here is the PGA Tour tournament level performance data presentation by Clinton Baker. In this project, I'm going to analyze a PGA Tour tournament level performance data set. This data set was provided by, it was found on Kaggle. It's called PGA Tour Golf Data from 2015 to 2022. The author is Rob Mula. This is the URL. It's publicly available. Within the data set, it's player performance data related to specific tournaments. So there's a tournament ID, player ID, and then associated player stats from that tournament. My two primary research questions are: one, which strokes gained components are most strongly associated with better finishing positions? Strokes gained is a metric used in PGA Tour analytics to identify areas that players are performing better than the competition. And two, what statistical differences exist between players who finish in the top 10 and those who do not? So let's jump into the project. We import our CSV file that we got from Kaggle as a data frame. Here's what that data looks like. These are a couple of rows just to kind of get an example. And when I started my, verification and cleaning process, I just used various pandas methods to try to understand the data, kind of do some exploration. There's 36,000 rows. POS is position. That is the position that they took in the tournament. And it looks like there's a lot of NAs on that. It's my understanding that that would represent a player who did not finish the tournament or who did not make the cut, which essentially means they didn't make it to the final rounds of the tournament. And so that's kind of significant and something we need to be aware of. There's also some NA values for some of these are the columns that we're going to be looking at a lot. SG stands for strokes gained. We have putting around the green, the approach shots, and OTT is off the tee, I believe. There's like tee shots, hitting drivers and stuff. Okay, so those are another thing we need to be aware of, though. And, we're using the describe method, just a better look at what kind of data we're working with. I went ahead and here's just a little bit of data cleaning in a way, or whatever you want to call this, modification. I went ahead and added a column top 10, just a Boolean based on if they are, if their position is less than or equal to 10, which will make it easy to identify who's a top 10 player and who's not. Here's a sample of that, just to kind of get an idea of what we're working with. Here are some of the methods I used to explore the data. I did some digging. I would say the data set's pretty clean as is. Looked nice. It's solid. It was well structured, all that. The one thing that I really noticed that I felt like might be a problem was I found some 999, as you can see here, from the position column. When we describe that, we're looking at the max and we see a 999. That doesn't really make sense in respect to like the PGA Tour. There's not really a 999th place. And so I didn't know if that was either data like entry problems or if that was a placeholder or something that they use. And when someone drops out, maybe it stayed at 999. But either way, I cleaned that up and just replaced it with NAN or, NA, just to make sure that, I'm not using that as some kind of number down the line. That felt like the key cleaning that really needed to happen with this particular data set. Other than that, things kind of made sense, looked good. And I might do a little bit of, I do end up doing a teeny bit of cleaning down the line, but overall, we're ready to roll. So here's our exploratory data analysis. And the goal was to, examine strokes gained variables, identify relationships that may explain differences in tournament performance, as we explained earlier in our objectives of this project. One key note was that I only wanted to use rows with valid finishing position and non-missing stroke gain values. So here I have these 4 columns. These are the stroke gains columns that I chose to focus on. I didn't want any aggregates. They have stroke gains total and all that. I thought that would just cloud some of the exploration that I'm trying to do as I'm trying to identify which of these areas is most significant. And so I chose to focus to just these. We also have position, obviously. That's important to understand how a player performed in a given tournament. And so those 5 columns are what I'm going to look at with this EDA data frame, exploratory data analysis data frame. So I dropped all NAs from those, made sure it's a copy. I don't want to modify the original data frame. So here's our shape. We obviously lost a lot of rows there. We're down to 16,000. Here's our correlation matrix. That seemed like a good way to explore, I guess, these 4 disciplines, if you will. And what we found was a negative correlation with all of them. And I wasn't surprised by that, but the strongest negative correlation was with the approach game, strokes gained approach. And so I think this is a good indicator that the players who gain more strokes with their approach play, or essentially are good at their approach play, seem to have the highest correlation with having a low, we wanted a negative correlation, right, for a lower position, which would be a lower placement in the tournament. Here's a little plot. We can visualize this with a scatter plot. We have strokes gained, and then I did invert, as you can see here. I inverted the y-axis, made more sense. I think it just feels more comfortable, because in this case, 0 or 1, we don't actually go to 0, but 1 would be more desirable. So these are better outcomes up here, worse down below. And as you can see, there's kind of a trend here that higher strokes gained is correlating to a better position. This little comparison that we did here just filtered out the data frame for players who have true for top 10, and then those who do not have true for top 10. And then we grabbed the average of each of those on their, grab their average, and now we can look at the top 10 mean and the non-top 10 mean related to these 4 columns. And so as you can see, there's a pretty big gap between top 10 players strokes gained in all 4 categories and not top 10. And here's a nice little visual, another little visualization bar chart here. And I think it's very apparent that strokes gained are much higher for high performers. But specifically, I think this does a good job of visualizing that the approach and the putting seem to have the strongest correlation with the high performers. And specifically the approach being the most significant. Another way to visualize and look at this was difference. So we're looking at the difference between the top 10 and the non-top 10 in each of these disciplines. And, the top 10 players gained 0.75, roughly 0.75 more strokes on approach per tournament than non-top 10. So again, this seems to be a very significant factor in success on the PGA Tour. And as a summary, really, I'm just driving home the point that, with these few techniques that we're looking at, it's becoming more and more apparent that the approach game seems to be the most significant area to focus on. But putting is close behind. And so now we're going to jump into some linear regression models. So using SciPy.stats, we're going to take a look at this pretty simple linear regression model. And we're looking at the relationship between strokes gained on approach and finishing position. So with the slope, it's negative 11.95. So for every stroke gained, that's a pretty substantial amount of positions and placement. And this is an approximation, obviously, but nonetheless, it approximates to 11.95 positions or places, I guess, gained for every 1 stroked gain on the approach game. So it's obviously a pretty significant factor in modeling of player success, so we can kind of model outcomes that way. R squared of 0.23, so we have 23% of the variation in finishing position is explained by the approach game. Went ahead and did the exact same linear regression model with the other categories here. And, we're seeing similar slopes, but what we're seeing here is that the approach game accounts for a lot more of the variation with the higher R squared here. And so I think this is just another way of putting more value on that approach game, that's going to be a key predictor in outcomes. And next we were looking at top 10 probability as a function of strokes gained. So potentially another way to model player success based on strokes gained. So we went ahead and created 4 bins. We had the highest performers. The highest performers and the lowest performers. And we went ahead and looked at a top 10 rate. So we are averaging, the Boolean value here for top 10. And a better way to visualize this is with the chart. But as you can see, this would be the high performers category, almost 36%. Let's see, what was it? It was actually a little over 36%. We're in the top 10 with the high strokes per gained crowd. And is this, let me double check this. This is strictly with approach. So the players who are strong in the approach category had a really high prevalence of top 10 probability. It was likely that those who performed well with the approach shots were in the top 10, and it was very unlikely that the low performers, when it came to specifically the approach game, would be in the top 10. And so this is just another visualization, another way to look at this and recognize the value of the approach game. In conclusion, truthfully, the biggest takeaway from this is simply that strokes gained in the approach game seems to be the most significant factor in player performance on the PGA Tour. And plenty of other metrics matter, even metrics that aren't in this data set. But within this data set, specifically putting and around the green play, off the tee performance, they all also contributed. Specifically putting seemed to contribute the most, but they were smaller in magnitude than the approach game. Thank you.